Okay, so what do you think about number one?
So it would be adding just one.
Right.
Wait, my thing keeps closing. Okay, two.
Excellent. Good. Yeah. Good. Okay. For number two.
Uh, there.
Okay. How about for number three?
Wait, the shade and add. Okay, so then it would be it's kind of bad, but like that.
Yeah, good. Good. How
And
about
then,
four?
huh?
Number four.
Oh, okay, yeah. It would be it would be- what the just add on to this. It would just add more like that.
And you want to add one more right here as well. So, okay, cool. Yeah, you get the idea. Like there'll be
Yeah.
one right there. We draw a new pentagon, of course, but
Ew. Yeah.
now let's move on to
This one?
yeah. What number do you think would come next?
Uh,
Okay. Okay.
one.
Good. Mhm. Mhm. Good. Conjecture is like a theory that you can eventually prove. So you notice that like 1 times 3 is 3, 1 times 5 is 5, 3 times 3 is 9, 7 times 3 is 21, 7 times 7 is 49. So you notice something. Every time I multiply two odd numbers, the product is always odd. So that's just called a conjecture. It's
Okay.
it's it's like or a hypothesis. That's another way to think about it. Now show that this hypothesis is false by finding a counterexample. So any four-side polygon is a square. Well, that's four sides, but it's a rectangle. Or the square of any integer squared is itself. Well, if I square root -4, it's not itself, it's 4. The squares always yield positive numbers. That's so that it's a function, but I don't have to get into that argument today. The average of any two consecutive even numbers is an even number. Well, if we have 4 and 6, what's the average of 4 and 6? 5, right? So anyhow, um, that was just more just like kind of review stuff. But now we're getting to more of the heart of the matter. Um, we're starting to get into something called proofs. But we like you have to like prove these things, and proofs can be pretty intense. But we're kind of doing the building blocks right now. First off, you can show me a drawing for number one. xy equals yz. So y is the midpoint of xe, but give me a counterexample.
A counterexample of what? Y is the midpoint?
So maybe that's not true.
But isn't that true?
Well, what if you drew it like this?
Isn't it still the midpoint?
No, because xz is not a line,
Oh yeah, it's an angle.
right? Because here's xe truly. And why is that the midpoint of it?
Okay, so this one. You know, my dad has made me do 2 IXLs a day, and
Okay,
I logic, like a lot of logic.
good. Yes, that's a good idea.
Is that this like conditional stuff?
Yeah, actually, I have an Excel account, but before we do that, yeah, exactly. If I stay up until 3 a.m. doing homework,
You will be tired.
sure, yeah, right. Um, right, whatever. But let's talk about if-then statements. So if-then statements are conditional because there's a condition. If this happens, then this happens. The first part is called a hypothesis. If it is raining, then it's a conclusion. Then there are clouds in the sky. Great.
Yeah.
So you say if an animal is a bird, then it has feathers.
That's yeah.
Or if they are so if two angles are a linear pair, then the angles are supplementary. So if you look at C, D, and E, how would you can just tell me out loud, say out loud. Um, well, how would you say that as an if then statement?
Um, and like an if-then statement.
Yeah. You can say if an angle is
90 degrees, then it is a
then it's
right.
the right. There you go. Or you could say the other way around. If it's a right angle,
Then it
then
is
it's 90
90.
degrees. And if both are true, we call that biconditional. We'll talk about that also. What do you think about D? How
If
just
is 9, then n squared equals
yeah.
81.
Now, if you reverse it, that's not necessarily true. Because if n squared equals 81, n could equal 9 or negative 9.
Oh yeah.
So you gotta be careful there. Well,
And then if
if you're an Alcatraz tourist, then you're
you're
in California, right?
okay.
Right? Because you're not gonna be in Nevada or Washington or Oregon,
But
Hawaii.
that wouldn't be that can't be reversed because if you're in California, you're not necessarily Alcatraz.
Correct. Right. If you're in I'm actually at the Stanford campus right here. So I'm in California. You're in Fremont, right? So, yeah. Actually, crazy. I've never been to Alcatraz in my life. Is that crazy?
I
Yeah.
haven't.
Yeah. Maybe I'll take my kids one of these days. But anyway, yeah. Never been to Alcatraz. It's kind of crazy.
I was supposed to go in COVID, but then COVID happened.
Right.
So
Of course. Yeah. Yeah. Negation is just when you say the opposite. So the ball's red, the ball's not red. Cat's not black, cat is black. It's just saying the opposite.
yeah.
Converse is when you switch hypothesis and conclusion. So like, if you're a tourist in Alcatraz and you're in California, or if you reverse it, if you're in California, then you're a tourist in Alcatraz.
And then contrapositive is if you change both, right?
Correct. Inverse is you just say the opposite. If you said like um if you don't have a right angle, then you're not 90 degrees. So that's inverse when you just negate. In contrapositive, you do both, right? Just so you know, contrapositive is always logically equivalent to the original statement. So good example would be, so obviously Fremont's in Alameda County, right? So I'll just type it up. If you live in Fremont, then you are an Alameda County resident. That's true, right?
Yeah.
Now, if I said this, the converse, if you are an Alameda County resident, then you live in Fremont. Well, that's not true because you could live in Newark or Union City or San Leandro or Oakland, right?
Yeah.
So that's the converse. Now, if I said this, if you don't live in Fremont, then you don't live, then you are not an Alameda. Again, that doesn't make any sense because again, you could live in Newark and still be an Alameda County resident. Then the last one, if I do both, right? If you are not an Alameda County resident, come on, man. Shit. Sorry. Here we go. Then you don't live in Fremont. That's true. If you're not an Alameda County resident, of course not be living in Fremont. I'm not an Alameda County resident. I don't live in Fremont. I live in, well, I live in a lot of other places. I stay in Redwood City and my family's up in Sacramento, but yeah. So I mean, so that's a kind of logic that's going on there. Okay, so let's start with the conditional statement, the original. If you're a guitar player, you're a musician, right?
Okay, so then this would be, oh,
So the converse, just tell me what would the converse be?
oh, it would be if you're a musician, then you're a guitar player.
Correct, which is not true because you could be a vocalist, you could be
Yeah.
a drummer, yeah, a pianist, a violin player, um, playing the trumpet. I don't know. Inverse, if you're not a guitar player, then you're not a musician. Not necessarily true. But then what would the contrapause would be?
Uh, if you're not a musician, then you're not a guitar player.
Correct. That's logically equivalent. You get the idea, so we don't have to do the next one. So decide whether each statement is true about the diagram. Is AC perpendicular to BD? Yes, it is. Is it A, B, and C be linear pair? Yes. Are EA and EB opposite rays? No.
Symbol mean the same as?
What was that?
Does this symbol mean the same as?
No, that's perpendicular.
Oh,
Perpendicular means form right angle. The same as means that's congruent. Looks like this.
okay.
Okay. So now, what do you think about the next one? JMF and FFG.
Why is it like, oh, I'm using some smart pen.
Yep. Yep.
Okay. Midpoint M is the midpoint of H.
Whoa, you know that? You're going based on looks. Is there enough evidence to back that up?
No.
I don't know that exactly. You're gonna be highly critical right? So assumptions will kill you in geometry. You never ever want to make assumptions unless you got evidence, hardcore evidence to back it up. Okay, and then what about the last one? Really? Is it right angle? That's be
Oh, yeah.
right. Is that be right angle right here? I don't see one. So yeah, it's not there. So biconditional is when you could go do the reverse. Like, if an angle is 90 degrees, it's a right angle. If it's a right angle, it's 90 degrees. So that's what biconditional means. So if two lines intersect to form a right angle, then they're perpendicular. So the way you write the biconditional, you would say, I'll type it out. Two lines intersect. So I don't use the if statement to start with. Intersect to form a right angle if and only if. Okay. So try next one. And actually, maybe you could try typing on the screen. That helps.
Okay. So, wait, so biconditional means that they're like both true?
Both directions.
What?
So if you reversed it, it would still be a true statement.
Okay.
So you can say Mary is in theater class if and only if she's in the fall play. I already told it to you. There you go. That's how you say it. Mary is in the theater class if and only if she's in the fall play.
Wait, what? I don't get it.
You take the statement Mary's in the theater class. If and only if.
Oh, okay.
So what you're saying is that if she takes theater class, she'll definitely be in the fall play. Or if she's in the fall play, she took theater class.
Okay.
They're both true statements. That's all. Don't over. I know we can easily overthink these sometimes. Same with the contrapositives. We can easily overthink those as well. Okay, deductive reasoning. Let's talk about that. Let's not worry about that. That's kind of a dumb warm up. So if you think about A equals B and B equals C, then of course A equals C, right? Because guess what? A and C both equal B. And B is like a bridge between A and C.
A, B, and C all equal each other?
Correct. So now that's deductive reasoning. See, deductive comes from a word to deduce. To deduce means what follows. What follows next. And geometric proofs, which will be a big thing we'll talk about next time we meet, is all about deductive reasoning. Like, what's the next logical step? You ever do any coding, by the way? Have you ever done any computer coding? No, okay. Well, that's a lot of deductive reasoning. Like when someone writes a computer code, you have to make sure, like, okay, here's the first step, and then the next step, what follows. You have to understand the logic that goes into it. So if the measurement angle is 90 degrees and it's considered a right angle, the measurement angle is 90 degrees, then angle A is right.
That means angle B is also a right angle then? Oh, no, this is a different problem.
So here, Mary goes to the movies every Friday and Saturday night. Today's Friday. Then Mary goes to the movies.
Like, it's kind of simple. It's just
Yeah. Um, if Rook takes chemistry this year, then Jesse will be Rook's lab partner. If Jesse is Rook's lab partner, then Rook will get an A in chemistry. Well, he'll take chemistry. I don't know if he'll get an A. So, um, that's weird.
Huh.
I mean, it's true, but I guess so. Oh, the right new conditional statement. Okay. Hold on. Wait a sec here. Oh, you start with this, and then you say this. That's what you do. So you start by saying if x is bigger than 5, then x squared is greater than 25. Then you want to say, and since x squared is greater than 25, x squared is greater than 20. But anyway, kind of dumb. Let's look over here. If a polygon is regular, it means all the sides are the same. Then all the angles are congruent. Polygons regular, all sides are congruent. So here's how I would rephrase it. I would say sides of all sides of polygon are congruent. Hold on. What do they want me to do here? I'm not sure I understand that question. Let's just skip that one for now. Um, hold on. Let's skip that for now because I'm not really sure if I follow this logic here. Hold on. Try this here. Oh, inductive starts with specific observation and moves towards general conclusion. Got it. Okay. Got it. All right. That makes sense. So hold on. I still don't follow that. Yeah, that's general to specific. Okay, I see now, but I don't see how that applies here though. I mean, I guess this would be specific to general. So that's induction. Like that's what you're in, you know. This would be deductive. So this is inductive. But this would be deductive. You're going for something general each time. Actually, no. It returns to the ground. No, that would still be induction. You're going for something specific. See, this one right here, this is general. And that's specific. So that's deduction. Because in general, reptiles are cold-blooded. Specifically, parrots are not cold because you're talking about a specific animal. So that'd be deductive reasoning. Anyway, it's kind of dumb. Don't worry about it. This is the last thing we'll talk about. Last thing I want to talk about are postulates. Postulates are things that we always assume to be true. This actually does matter. So if you have 2 points, there's always a line that goes through 2 points. A line always has at least 2 points. If 2 lines intersect, the intersection will be 1 point. If you have 3 points that are not on the same line, then they'll form a plane. A plane has always at least 3 non-collinear points. If 2 points lie in a plane, the line containing them lies in a plane. If 2 planes intersect, the intersection is a line. Yeah, that makes sense. That's that over here. So these are things we always assume to be true. So they're like basically assumptions.
Okay.
And here's like a diagram, and like for example, angle AHB and BHC are linear pair, yes. But GFE, I don't know if they're all going to be on a line. We don't know that. Or BF and CE, no. So we don't know if those will intersect for sure. We'll finish off this example here. ABF is, yes, that is collinear. EBD, I don't know that for sure.
A, B.
EBD, I don't know if they're gonna be on the same line. AB is definitely perpendicular to S. We see that little symbol there.
CD. No, because there's no right angle.
Right, we don't, right. We can't assume that.
AF and BC.
Yep, they intersect at B. Yep.
Yeah. Okay.
Plane S intersects plane T. Yes.
Yeah, because yeah.
Okay, cool. So I think we're all good for today. So we'll skip next week, as you said, and we'll meet the week after on July 8th.
I mean, maybe I can ask my dad.
Let me know. Yeah, I'll make sure I'll send the work. So you have that. So
Okay.
cool. I'll see you later.
Bye. Thank you.
Bye.